This is Gia Freidenberg, and this is our fifth module in the ESL 345 class series. It's all about numbers, charts, graphs, and statistics. Well, $100 billion. I guess it's not as much as it used to be. But numbers can be very persuasive. The question is, what do these numbers mean? Take housing prices, for example. Here's a picture of an ordinary house in the United States. What does it cost? What should it cost? If you put this house in Newport Beach, California, the sale price could be $2 million. If you put it in Flint, Michigan, you might get $100,000 for it at best. Numbers need context. That's where statistics come in. Let's line up all the female high school graduates in the US from a single year, let's say 2022, and measure their height. What's the average height? It turns out that the average female is 5 feet 4.5 inches. Of course, some are taller and some shorter. In fact, they normally distribute themselves, if you have enough of them, like the image on this screen. This is called the normal distribution. So the average here in the middle where it says 0 and mean is 5 feet 4.5 inches, and that's called the mean, the average. Then we measure by how much each individual young girl graduate varies from the average. We finally found, after a lot of tedious measuring, that the average by which each girl deviates or differs from that mean is 2.5 inches. 68% of all those girls we measured are between 2.5 inches shorter than the mean and 2.5 inches taller than the mean. You'll see it says 34% plus 34% in the middle. That's 68. So 68% of all the girls are between 5 feet 2 inches and 5 feet 7 inches. That means that the remaining 32% of all girl graduates are either shorter than 5 foot 2 or taller than 5 foot 7. The average of 2.5 inches by which they differ from the mean is called the standard deviation. And you can see here's 1 standard deviation, 2 standard deviations, 3 standard deviations, and that's pretty much about it. But let's look at some other folks. Let's look at some tall people. Basketball players. The image on the slide shows the distribution of the height of NBA basketball players in a bar chart. A bar chart has 2 axes. That's 1 axis and 2 axes. The vertical axis on the left is probably the number of people. It looks like 52 of them are 6 foot 9 inches tall up here. Then the chart slopes pretty quickly off to the right. It looks like about 56 of them are 7 feet tall or taller. I can't tell what percentage that is, but it's not huge. There are many more players on the left of the tallest bar. So what do we conclude from this chart? I would say that NBA players come in many different heights from 5 foot 9 to 7 foot 3. The majority are from around 6 foot 6 to 6 foot 10. There are more players shorter than 6 foot 9 than there are those over 6 foot 10. Well, let's take a look at a pie chart. That pie looks good. When we're looking at percentages, a pie chart is a convenient image. The whole pie is 100%. Each quarter of the pie is 25%. Of course, we can cut slices of any size from this pie, some big and some small. Let's think of the US government in a given year as 100% of the pie. Who gets which slices out of that pie? Well, here are the US expenditures in dollars. It doesn't say what year this is, but it stays pretty much the same. Oh boy. Healthcare. Healthcare is a large amount. Almost 3/4 of this pie, healthcare, Social Security, defense, and homeland security, take up 70% of the chart. There's not a whole lot left for other causes. So, what does this mean in dollars? A lot of dollars. Healthcare is $1,629 billion. Pensions, $1,327 billion. Defense, $1,115 billion. And welfare, $704 billion. There's not a whole lot left for all these other little tiny slices of the pie. Now, 1,000 million is 1 billion in the US system. The total US federal budget is in the trillions, almost $7 trillion. Almost half of that actually is deficit spending, meaning that we borrow the money. Let's take a look at how we count large numbers in the US. Here's an image of some very large and some very small numbers. The scientific notation in the third column here shows that 100 is 1 times 10 to the second. We call that 10 to the second. 1,000 is 1 times 10 to the third, and so on. So if you look at it, a number 1 with 6 zeros here is 1 million. 1 with 8 zeros is 100 million. 1 with 9 zeros is 1 billion. And 1 with 12 zeros is 1 trillion. And our budget total is nearly $7 trillion. Yikes. The origin of this phrase, lies, damn lies, and statistics, we're not quite sure about who said it, but we know that it was written down by the author Mark Twain. It's not exactly certain whom he is quoting as having said that. The phrase has become normal in everyday discussion of the murky art of statistics. Since this is not a math class, thanks to the power that be, we will leave it there. Numbers, statistics, charts, and graphs are useful for your argumentation in writing. They are very persuasive. Just be sure you know the source of your numbers. Do you really trust that source? Do you know how those categories are defined? Answers to those questions will become very important later in your university career.